Hello everyone, I am Dr. Godandaraman. In this section, we are going to discuss with multiple server infinite capacity problem, MMS infinity first come first serve related problem. See, the problem is there are 3 typists in an office. Each typist can type an average of 6 letters per hour. If letters arrive for being typed at the rate of 15 letters per hour, what fraction of time all the typists will be busy? What is the average number of letters waiting to be typed? What is the average time a letter has to spend waiting and for being typed? So first of all, the given problem to check is a single server or multiple server. Here 3 typists is mentioned, therefore the problem is multiple server. Then check the problem is infinite capacity or finite capacity. Generally the finite capacity in the given problem to mention. So up to waiting time, up to some number customers or whatever the detail is given the problem when it's a finite capacity. But here nothing to mention. So therefore we can consider the given problem is infinite capacity. So multiple server, infinite capacity. This is a model finalized. Next, lambda value, mu value to check. What is the given lambda value? Lambda is a arrival rate. So arrival rate is nothing but letters arrive is nothing but 15 letters per hour. 15 letters per hour. Therefore, the lambda is nothing but 15 letters per hour. Then the typist can type average. So service rate 6 letter per hour. So mu is service rate 6 letter per hour. Then the server 3. So lambda arrival rate, mu service rate, and then server. So this is a arrival rate, service rate, and then number of server. Now next, what is the question? What fraction of time all the typists will be busy? When the all typists busy, so we have 3 typists, 1, 2, 3. So 1 letters arriving, so the one typist will type the letter. So 2 persons are free. Suppose 2 letters arriving, 2 typists busy, 1 server are free. So when 3 letters, 3 or more letters arriving, then all typists will be busy. So therefore the first question is nothing but what fraction. So what is the first question? What fraction of time will all the typists will be busy? So the probability of all typists are busy when is possible? 3 or more. So now the formula is nothing but probability of n greater than or equal to s equal to lambda by mu whole power s into p naught by s factorial 1 minus lambda by mu s. Now before that, because we know the value of lambda mu s, so now first you find p naught. P naught is probability of 0 customer. So the probability of 0 customer is nothing but summation n from 0 to s minus 1 by n factorial lambda by mu whole power n plus 1 by s factorial lambda by mu whole power s, then 1 by 1 minus lambda by mu s whole inverse. Now substitute lambda value, mu value and s value. When I substitute s, summation n0 to 3 minus 1. So I am substituting s value 3, 1 by n factorial, lambda 15, mu 6 power n plus. The summation only for the first term. So this term only summation. Therefore plus 1 by 3 factorial, s is 3, lambda 15 by 6 whole power 3 and 1 by 1 minus 15 by 6 into 3 whole inverse. Now this is a n from 0 to 3 minus 1, 2. 1 by n factorial 15 by 6 power n plus 3 factorial 1 by 6 and 15 by 6 power 3, and this is a 15 by 18. So 18 taking LCM, 18 minus 15, 3 by 18 whole inverse. For this term, see, when I substitute n0, 1 by 0 factorial 15 by 6 power 0 plus next 0 to 2. So n1, 1 by 1 factorial 15 by 6 power 1 plus the maximum up to 2, 1 by 2 factorial 15 6 power 2. So this is up to for summation plus this 1 by 6, this is a 1 by 6, therefore this 1 by 6 to cancel. Now we have 15 by 6 whole cube whole inverse. And this term anything 0 factorial 1 and 15 by 6 any power 0 1, therefore 1 plus 15 by 6 plus 1 by 2 15 by 6 square plus 15 by 6 cube whole inverse. Now using calculator to simplify, but don't forget here we have inverse. So only some of the students they are calculating only this term to calculate using calculator, but forget to taking inverse. So now taking inverse, the value is nothing but P naught equal to 0.0449. But the question is all typists are busy, therefore probability of n greater than or equal to 3 and then lambda by mu whole power s P naught by s factorial 1 minus lambda by mu s. So when I substitute 15 by 6 power 3 into 0.0449 by 3 factorial 1 minus 15 by 6 into 3. So this term is nothing but 15 by 6 power 3 and 0.0449 by 3 factorial 6 into, when I am taking this LCM, 1 minus 15 by 18. So 18 minus 15, so 3 by 18, this is a 3 by 18, 1 by 6. So it will be cancelled. So therefore 15 by 6 whole cube into 0.0449. Using calculator to simplify, this value is nothing but 0.7016 probability of n greater than or equal to 3 when all typists are busy. So this is our first question. And what is the second question? What is the average number of letter waiting to be typed? Number when is mentioned, it's a L. When is mentioned, L number. So this is a, what is a number of customers. So this is the problem. The average number of letters, waiting to be typed. Therefore this problem is nothing but waiting to be typed LQ. So LQ, because L is number of letter, waiting to be typed is a Q, LQ. The formula is nothing but 1 by s factorial into s lambda by mu whole power s plus 1 by 1 minus lambda by mu s whole square into P naught. So substitute s value. So 1 by 3 factorial into 3, 15 by 6 power 3 plus 1 by 1 minus 15 by 6 into 3 square into 0.0449. Now this 3 factorial 6 into 3 18, 15 by 6 power 4, and when I'm taking this 1 minus 15 by 18, so 18 minus 15, so 3 by 18, so 1 by 6 power square into 0.0449. So using calculator to simplify, this value is nothing but 3.5078 LQ. So this is a second answer. And the third one, average time letter has to spend waiting and for being typed. So the third one is nothing but average time. So average time is nothing but W. So average time a letter has to spend for waiting and being typed. So what is mean this? Average time is W. Letter to spend where? In the system. Typing is process is a system. Now to calculate WS. Now using little formula, WS is nothing but LS by lambda. But we know that using the little formula, from LS to calculate, first to LS to calculate. How to calculate LS? LS equal to LQ plus lambda by mu. So this is a little formula. So now substitute LQ value. What is LQ? 3.5078 plus 15 by 6. Now simplify this using calculator. The value is nothing but 6.008. So this is a LS. But the question is WS. So WS equal to LS by lambda. So 6.008 by 15. Now the simplification 0.40. So waiting time. Thank you.